Now we're going to talk about percents. And the first thing we have to do is understand percents. Well, if we take the word percent, we're not really trying to fool anybody. Per. We split this guy up. Per actually means to divide. And you can use this in your own life, right? If we go feet per second or miles per hour or pounds per square inch, all of those means that we're dividing, and those are rates. Cent, on the other hand, how many cents does it take to make a dollar? How many years are there in a century? Feet does a centipede have? That's approximate, but anyhow, it still means 100. So percents, all we're trying to do is to divide by 100 or make something a whole by making it into that total of 100. Now, I do this with you guys. So if I have you guys in class, right, you turn in a homework or you turn in a quiz paper, you get a certain points that you earn that is right out of it. So let's say you turn in a quiz. All quizzes in my classes are worth 10 points. All right. Let's say you get an 8 out of that. Most of you know that that's a pretty good grade or an okay grade because that does work out to 80%. But why? All right. Fact of the matter is, it still comes to that previous slide where it says percent is to divide by 100. If I again take this 8/10, I can actually make my bottom number 100 by simply multiplying it times 10. When I do the bottom, I have to do the top, and this number becomes 80 over 100. Here we have it. Divide by 100 is percent. And versus going vertical on this problem, especially when we type it into a book or type it into text, other than your math book, we like to see that as linear or on a horizontal. So percent is simply easier to write and takes up less space, less ink, as a symbol of percent. So yes, that is the same thing. Those are the reasons behind it. Now, as we progress through our studies today, there's some things I want to keep in focus, all right? We know that proper fractions, let's give you an example of a proper fraction, right? 2/3. A proper fraction is when our pieces of 2 is less than our total parts, which is 3 in this case. So 2/3. And if I make that into a decimal, that number is always going to be a number less than 100. If I made that into a fraction, I wanted it to be 1, that would have to be 3/3 would be 1, because anything divided by itself is 1. Which means I am now comparing proper fractions to improper fractions. And I'm comparing it to this number of 1. A proper fraction will always be less than 1. An improper fraction will always be greater than 1, or 1 is less than an improper fraction. And if I gave you a fraction, this fractional value as an improper could very well be, I don't know, let's say 11 over 7. So you had 7 total pieces of something, and you got 11 of them. Well, that doesn't make sense. It does if you change it to a mixed number, and a mixed number and an improper fraction are exactly the same thing. And immediately, because our denominator will always stay the same, 7 goes into 11 one time, and here's my remainder of 4, so that is 1 4/7. You're going to see that an improper fraction is greater than 1 because our whole number is 1 and we have parts of another. That's something to kind of keep in mind as we go through this, all right? Because our number of 1, when we start dealing with percents, a percent is actually divided by 100, which means is 100 over 100 gets us 1, which is this number we're all talking about. So a number, a percent, that is less than 100% is actually less than 1. A number that is over 100% is actually a number that's going to be greater than 1. Now, if we turn in our books, our book gives us these definitions, and you know, I don't mind definitions. And they're not wrong. It's just that I'm not a big fan of those guys. Let's get that off of there. All right. Changing percents to decimals. And changing percent to a decimal, your book says drop the percent symbol and move the decimal point 2 places to the left. And there's nothing wrong with that. But I ask you why. And most kids can't answer why in that case. Changing decimals to percents, move the decimal point 2 places to the right, and then put a percent sign behind or at the end of that number. And that is absolutely right. But here again, I asked the question, why? And most kids say that's because that's the way I've always been taught. And we've sometimes in our society have been taught the wrong things. So I kind of want you to understand what is going on and why. So let's go ahead and do a couple problems here. So let's take and let's make a percent into a decimal. And I'm going to go about this a little bit backwards, I understand, because, yeah, I guess I'm the math teacher. But I've got a percent. I've got 88%. I'm going to change it to a decimal. Let's go ahead and put my decimals up there. When I do that, the easiest thing to do is not necessarily take a percent to a decimal. The easiest thing for a percent to change into is a fraction, which is why I had the previous slide. This is actually 88%. And now I can understand why when my symbol falls off, my percent symbol falls off, I move my decimal place 2 places to the left, just as the book said. Because if I don't have a decimal on a number, my decimal always falls behind a number. And so on my 100, there's my decimal place. I'm going to move it 1 and 2 places to the right. Well, why 2 places? Because anything divided by 1 is itself. So I'm going to divide the bottom by 100, making it 1. When I do the bottom, I also have to do the top. My decimal place here is behind the 88. It also has to be divided by 100 or move 2 places to the left, which makes this answer now 88 hundredths. And yes, 88 hundredths is my answer on that guy. And if you remember what I said earlier, anything under 100% is going to be less than 1. This is a fraction, or this is a fraction is less than 1, as we could see in our fraction when we changed it. But it also is less than 1 on our decimal value as well. So let's go take a look at another number that might confuse us here. Let's take 6% and take a percent and change it into a decimal. Well, there it is to a fraction. I take my decimal 2 places to the left, take my decimal 2 places to the left, and now what do I do in this gap, right? I got this gap sitting there. Well, that gap is actually a 0, because a 0 in front of a number in this case does actually change the value of a number, but that's what was sitting there in the first place, which is 0.6 is the same as 6. So when I write my answer out, I end up with 0, and I like to have the 0 in front. A lot of people don't really care about that, but to me it really brings to light my decimal. And then I have that 0 where that dead space was, and 6. And here's that relationship. I've got a very, very, very small percent. 6% is not very big. So I should not have a very big number in respect to 1. And 600ths is, of course, not exact, but a very, very small number in respect to 1. And then the ones that kind of confuse us, we have 125%. I'm going to change it to a decimal. And here again, if our relationships stay right, we should say 125% is more than 100%, should give me a decimal bigger than 1. So let's see if that pans out. So we get 125 over 100, 2 places to the left, and I get 1 and 25 hundredths, which is obviously bigger than 1. So it did pan out. So yes, what the book says is true about knocking off the percent, making two decimal moves to the left. Well, let's see what happens when it goes the other way. So when I change where am I? From a decimal to a percent. So, decimal to a percent. Let's start off and let's go 7/10. We've got 7/10. We're changing it to a percent. Well, yeah, what it says is move your decimal place 2 places to the right and then plug in the percent sign. Well, we've done this problem. This is a direct proportion. What I want is I want 7/10 to equal something over 100 because percent is divide by 100. And what I'm trying to do is find out that top number. Well, if I don't know that top number, it automatically becomes n. I set that into a direct proportion, and yeah, don't forget, anything is divisible by 1. So I take 0, 7/10 times 100 is equal to 1n. Well, when I multiply by decimals, I multiply as if there were no decimals, so I get 700. And I count my decimals, right? So I have 1 digit behind my decimal, so in my answer I'm going to have 1 digit behind my decimal, which makes 770, and that is n. When I plug this guy back into this guy, I therefore get 70 over 100, which is 70%. And as you see what the book was seeing, move my decimal 2 places to the right, tag it with that percent sign. That is correct. But if you want some math to follow it up so you understand and can explain why, there it is. Let's have a couple more examples and then I'll not waste much more of your time. Okay, so let's go a small decimal. Let's go and let's make that into a percent. Well, my numbers just keep getting smaller and smaller and smaller. Yes, it's still move it 2 places to the right, tag it with a percent, or direct proportions. And we get 0.009 times 100 is equal to, in this case, n. So this would be 900. And I have 1, 2, 3 digits behind. So 1 digit behind, 2 digits behind, 3 digits behind. And there's my decimal. So I get 9/10 is n. When I plug this guy back in, I get 9/10 per 100, or 9/10%. And as we involve decimals into things, kids really do. They start freaking out about where it goes, and oh, there's way too many decimals sitting there, so it doesn't move the 2 places like the book says. In this case, you never miss it. You always know where you're at and why you're at. All right, so let's pick a number that's bigger than 1. Let's make it a percent. And we said, right, that a number that's bigger than 1 should be bigger than 100%. So this number should be bigger than 100%. We can even guesstimate a little bit, right? 3 is actually 3 times bigger than 1. So how many times bigger than 100% should we be? Well, hopefully 3 times, which is 300%. It's still a direct proportion. I want to get it to percent. Find out that top number, and away we go. So we get 3 and 1500ths times 100 equals n, and I get 31500, 2 digits behind, which makes it 315, and so I get 315%. Hope you enjoyed.